Continuing with lesson 1.6, we're in lesson 1.6b as in boy, and we're continuing on. Let's look at example 4. It says write 3/4 as an equivalent fraction with a denominator of 20. So it gives me 3/4, and it wants me to write another fraction, but in this one they want it to have the denominator of 20. And they want this fraction to equal this one, just be bigger numbers. It's kind of like saying, I have 1/2 and I want you to write that fraction bigger, so you might write 4/8. They're both equal to 1/2, but one just has different numbers, and that's what we're doing up here. They're giving me 3/4, but they want me to write it as a fraction with bigger numbers. In fact, they even specify they want to turn this 4 into a 20. Well, how do we turn a 4 into a 20? We multiply that 4 times 5. So if we multiply this 4 times 5 to give me 20, then I multiply the 3 times the 5. You always multiply by the same thing to get 15. So that, if we were to reduce it, would be 3/4. And that's what they're asking you to do there. So the next thing we're doing in 1.6 is reciprocals and multiplication with fractions. So when you've got a multiplication, or, well, let's start out with reciprocals. Reciprocals are basically turning a fraction upside down. So if we have 2/3, its reciprocal is 3/2. If we have 4, that's really 4/1, right? And the reciprocal is 1/4. If we have 86 107s, the reciprocal is 107/86. That's pretty much all a reciprocal is just flipping the whole thing upside down. So let's look at some multiplication. 3/4 times 5/7. Do you remember how to multiply those? We multiply the numerators and we multiply the denominators. And then we reduce if we can. In this particular case, we can't reduce. Example 6, we have 7 and we're multiplying it times 1/3. Whenever we have a whole number like 7 that's not in a fraction, all we do is put it over 1 and it becomes a fraction. So then we multiply our top numbers and the bottom numbers and we get 7/3, and that cannot be reduced. When we have something like 2/3 and we're cubing it, remember cube means that we're going to take the number times itself 3 times. So what's 2 times 2 times 2? It's 8. What's 3 times 3 times 3? 27. And we're done. Okay, so that's multiplication. Let's continue on. Example number 8. Example number 8, we got -3/4, and we're multiplying it by 5/7. And we multiply the numerators, multiply the denominators, put a minus sign on it, because that's what this is right there. And we're done with 15/28. When we take -6 times 1/2, that's the same as 6/1. Multiply the top numbers, multiply the bottom numbers, and lo and behold, 6/2 reduces. 2 goes into 6 3 times, and we get -3. Now when we get down to the C part of example 8, we have -2/3, and we're multiplying it by -3/2. So we multiply the numbers on the top, and we get -2 times -3 is +6. Negative times a negative is a positive. 3 times 2 is 6. Any number over itself is 1. Alright, so let's jump to example number 9. Example number 9 wants you to find the reciprocals of the numbers. So, if we have 5, the reciprocal is, well, 5 is the same as 5/1. The reciprocal is 1/5. We flip it over. -2, writing that as a fraction, we get that. The reciprocal is -1/2. Notice this negative sign. Right here it's on 2. Right here it could be on 1. It could be just in front of this line here. It doesn't matter. When you have a fraction with one negative, you can put it anywhere you want. You can put it here, you can put it here, or you can put it here. They all mean the same thing. Not one of them is right, one of them is wrong. It's just wherever you want to put the thing. when I have negative 3/4. The reciprocal is 4 over 3 with a negative sign. The negative doesn't change. Now let's do some division. When we divide fractions, one of the things that's nice about the division of fractions is there's no such thing. Yay, we hate division. So if we have 2/3 and we're dividing it by the fraction 5 over 7, all we do is we take the division sign, turn it to a multiplication, take the second number and turn it upside down. Then we're just multiplying. And that's our answer. So there's really no division. It's just turning the second number upside down and multiplying. Like that. Doesn't get any easier. If we have 8 and we're dividing it by negative 4/5, we make that into a fraction. So we write 8 over 1 times, and we're going to turn the 4/5 over, multiply, and we get negative 40, multiply, and we get 4. What is 40 over 4? They're both even, so I know they reduce. 2 goes into 40, and 2 goes into 4, but 4 also goes into 40 10 times, and 4 goes into 4 1 time. So our answer is actually just negative 10, because we don't have to put it over the 1 there. Alright, so let's continue with 1.6, and this is adding and subtracting fractions. Adding and subtracting is the part that's not so fun, because the rule when you're adding and subtracting fractions is the bottom number has to be the same or you can't add them. And if they're not the same, you have to make them the same. So right now they are the same, and whenever you're adding fractions, you only add the top number. So we take 3 plus 1 is 4, and we put it over 8. And then 4 over 8 reduces, because if we do the product of primes, it's 2 times 2, and 2 times 2 times 2. Those give you 8. And remember I said you could cancel like this, and cancel that one with this, and whenever you cancel everything on the top, there's actually still a 1 there, and that is over 2. So 4h reduces to 1/2, but you probably already knew that. What if we have something like x plus 5 over 8, and we want to subtract 3 over 8? Oh goodness, what are we going to do with that? We're just going to, since the denominators are the same, we're just going to write it as x plus 5 minus 3. And we always put it over the denominator, which will be the same. So 5 minus 3 is 2, so that becomes x plus 2 over 8. And you are done. Now what happens if we come up with a problem that looks like letter C? Letter C says 9 over x minus 3 over x. Do you know what x is? No, we don't know what number x represents, so we're just going to leave it alone. It's the same here and here, so we have common denominators. We just have to subtract the numerators, and we get 6 over x, and we're done. That's all you can do. When you get D, we have 3 over 7 plus 2 over 7 minus 9 over 7. Denominators are all the same, so we can just go ahead and add the numerators. So we get 3 plus 2 minus 9 all over 7. Well, what's 3 plus 2? 5. Minus 9 over 7. And remember what we've done before. We put a plus sign there and a minus sign there. And the signs are different now because we're adding. Signs are different. So we take the difference, put the sign of the largest number on there, and we put it over that 7 there, and we get negative 4/7, and we're done. Okay, so last part of this video just has to do with definitions, the least common denominator. And the least common denominator means that when we have a fraction and we have another one, so we have 1/3 and we have 1/4. Least common denominator is there's some number out there that both 3 and 4 will go evenly into. And I not only want a number that 3 and 4 will go into, I want the smallest number that they'll go into. For example, 24. 3 goes into 24 8 times. 4 goes into 24 6 times. Well, that's great. But is that the smallest number that they both go into? What if I were to try, well, let's see, what goes into 3? Well, 3 goes into 9, but 4 doesn't. So that's not a common denominator. It's not common. Let's see. 4 goes into 8, but 3 doesn't go into 8, so that doesn't work. How about 12? 3 goes into 12 4 times, 4 goes into 12 3 times. They both go into 12 evenly, and that is the smallest number that both 3 and 4 go into. So that ends up being the least common denominator for those. So what does that mean? Well, let's look at doing some factor tree stuff, and we'll start on the next video with that.